Section 13.2 is on the acidity of alcohols and phenols. Alcohols can be deprotonated with a strong base. And because they can be deprotonated, that means that they are acidic. For example, phenol can be deprotonated with the strong base that we use. One of the strong bases that we use is sodium hydride, NaH. It's a very strong base, stronger than sodium hydroxide. And we just get the hydrogen from the OH group coming off. I've drawn in lone pairs that I didn't draw. There we go. Lone pairs, negative charge on the oxygen. We refer to this as an alkoxide. I think that's terminology that we used last quarter as well. The deprotonated form of an alcohol is called an alkoxide. This particular one is called phenoxide because it is the deprotonated form of phenol. Here's another example. You can deprotonate with just straight up sodium metal. It doesn't have to be sodium hydride. You get that guy right there. Or you can use lithium metal or potassium metal instead of sodium metal. The acidity of the alcohol, like how easy it is to deprotonate the alcohol, depends on the stability of the alkoxide that you form during the deprotonation process. So the easier it is to deprotonate the alcohol, the more acidic an alcohol is, the more readily it will be deprotonated. Totally depends on the stability of the alkoxide ion. It doesn't have anything to do with the strength of the base that you're using. It's all based on the structure of the alcohol and therefore the structure of the alkoxide ion. If you have a stable alkoxide, or if you make a stable alkoxide, that means that your alcohol is acidic. So the more acidic your alcohol is, the more stable the alkoxide is. It's like a chicken and an egg thing. It's hard to say. It's hard to know what the right order it is to describe this. Do you say that a stable alkoxide is going to come from an acidic alcohol, or do you say an acidic alcohol is always going to produce a stable alkoxide? The two concepts are totally intertwined. They can't be separated from each other. An acidic alcohol is acidic because it produces a stable alkoxide. However, you need to jam that into your head to make it make sense. The stability of the alkoxide depends on three factors. The first factor is resonance. If we look at these two alcohols up here in the deprotonation process, and we wanted to know which of these two alcohols is more acidic, this one or this one, phenol or 2-pentanol, which of these two is more acidic? If we wanted to determine which of these two is more acidic, we would look at their alkoxide ions that are formed, and we would compare the two alkoxide ions, and we would say that this alkoxide is more stable than this one, because this one's got double bonds and the potential for resonance, and this one over here has got no resonance going on. So this is the more stable alkoxide, which means that this is the more acidic alcohol, and this is less acidic because its alkoxide is less stable. If we can't use resonance for comparison, the second factor that we're going to look at is induction. And in simple terms, this just means if you've got halogens, they're going to stabilize the alkoxide. And the more halogens you have, the better. And the closer that they are to the OH group, the better, or the closer they are to the oxygen, the better off you are as well. And if you don't have induction as a factor, then you're going to look at branching of the carbon chain. And the less branched your carbon chain is, the more stable it is. The more stable the alkoxide is. And if you don't have any of those three factors to rely on, then you're going to need to look it up in a book. Look up a pKa. Because these are the three factors that we use for qualitative stuff. So let's look at a couple of examples of induction. If we had this alcohol versus this alcohol, and we wanted to compare the stability, the acidity of the two, we would say that this alcohol is more stable than this alcohol because it has a halogen on it, and that halogen is going to stable the alkoxide, and the stable alkoxides are related to a higher acidity. So there's that. This one's more acidic. If we wanted to compare these two alcohols, we would say that this alcohol is more acidic than this one. This alcohol has branches on it. This one doesn't have any branches. The fewer branches you have, the more stable your alkoxide is, and the more stable your alkoxide is, the more acidic your alcohol is. You can practice this concept with Skill Builder 13.2 and problems 13, 5, 6, 33, and 34. All of these are sets of alcohols, pairs of alcohols, and you just have to pick out the one that is the most acidic to give you. Some of them are trickier than others, but basically it's just applying these concepts and picking out the most acidic alcohol. And your study question for this section is, how do you determine the stability of an alcohol?